Alright, this is Mr. Gillum, and today we're going to learn how to add and subtract fractions, but there's also going to be variables involved. And so when we look at these adding fractions with variables, it's very similar to adding fractions without variables. And so we still need to find the least common multiple between the two denominators, also known as the common denominator. So we're going to look at the bottom of the fraction on each one. So in the past, we've had like, oh, if this was a 3 and this was a 5, we would know that the least common multiple, or the common denominator, those are the same thing, just different names, will be 15, because 3 goes into 15 and 5 goes into 15. And we could also find that least common multiple by writing a list out of numbers of 3 and 5 until we found the first one that matched both lists. Okay, so find the least common multiple for the denominator. Okay, we also call that the common denominator. Now, whatever I multiply the bottom of the fraction by to get to 15, which is 5 in this case, I would multiply the top by the same number. Or in this case, when I'm going from a 5 to a 15, I would multiply that 5 by a 3 to get to 15. I would multiply the top as well. Now, the reason I can do this is because we just learned the identity property of multiplication. And I know that the fraction 3/3 is the same as 1. Anything times 1 is still the same. So I'm allowed to multiply the bottom of the fraction as long as I also multiply the top of the fraction. Because in essence, what I'm doing is just multiplying it by 1. And that's what the multiplication identity property says. Okay, so that's allowed to do. All right, so that would be step 2. And then what I'm going to do is I'm going to add whatever's up here together. And I know I'm talking about this number of parts. So after I multiply, I'm going to add those on the top, or subtract. I'm going to leave the number of divisions the same. The denominator is going to stay the same. And then on the top, there might be like terms, there might not be like terms, but I'm going to combine like terms appropriately. All right. So let's take a look here at some examples. And as you can see, instead of like 2/3 plus 4/5, or 5/3 plus 4/5, or some sort of fraction plus fraction, we have x over 3 plus 4/5. Okay. Now this might be a little new to you because you've never done addition with fractions and variables at the same time. But I can tell you it's very similar. So I just so happened to pick 3 and 5 on the last slide. We would like these to be in the same number of divisions. Okay, this x is divided into 3 parts, and this 4 is divided into 5 parts. But what I would rather have them is divided into the same number of parts. So you can make a list like we just did if you're not sure what the least common multiple is. Mr. Gillum has a pretty good grasp on his multiplication facts, so I know right away, what I notice is that 3 and 5 would share a least common multiple of 15. Okay, so I'm going to write it just like that for now. Over 15 plus over 15. I know that's going to be my new denominator. But now I need to decide, what do I multiply 3 by to get to 15? Well, 15 is the 1, 2, 3, 4, 5th multiple of 3. So I know 3 times 5 would be 15. And same way with the 5, I would multiply it by 3 because 15 is the 1, 2, 3rd multiple. And 5 times 3 is 15. However, I need to make sure if I multiply the denominator of a fraction, I also need to multiply the numerator of a fraction by the same number. Okay? So I'm going to go ahead and I'm going to multiply straight across. 5 times x would be 5x. Okay, I'm going to multiply 5 times x. I'm also going to multiply 4 times 5. 20. All right. I'm glad I caught that before we got too far. Should not be a 5 up there. It should be a 3 because 3 over 3 would be equal to 1. So 4 times 3 is what I'm doing, which is 12. All right. Now, like we have always done, if it was just 5/15, so let's just pretend if it was 5/15 plus 12/15, we would just add them together, 17/15. However, it's not quite what it is. This time we have an x on it. So when I add 5x plus 12, those are not like terms. So I just need to keep them separate. We call that a binomial when there's 2 terms. The 5x and the 12 are both on the numerator, and the only thing on the denominator is the 15. Okay? So that's going to be my sum of those 2 fractions. All right? We can't squish the 5x with the 12 because they aren't like terms. So looking at this next example, and again, I like to think of, I just use my multiplication facts to decide my least common multiple, but if you need to write a list, that's fine too. 6, 12, 18, and then I have 3, 6, 9, 12, and the first one that I notice they have in common is 6. All right, so that's going to be my least common multiple, or my common denominator. Now, I notice that 6 is already 6, so I'm only multiplying it by 1. It's the first multiple of 6. So I also need to multiply the x by 1. Or what I'm really doing is multiplying it by 1 over 1, and that's where I'm going to get my next fraction from. 3, however, 6 is the 1, 2 second multiple of 3, so I know 3 times 2 is 6. And if I'm going to multiply the 3 times 2, I also need to multiply the 4 by 2. So in essence, again, this fraction is the same as 1, and the multiplication identity property says that if I multiply it by 1, it's still worth the same amount. It keeps its identity, even though it might look a little different. So on the first fraction, I haven't done this part yet. I've already done this. It's right here. But 1 times x is x. We don't need to write the 1 in front of the x because we know there's a 1 there. And then we've already done this part. It's down here. And we're going to do 4 times 2, which is 8. So again, this is just exactly like what we've done with fractions in the past. We now have them in the same number of divisions. X is into 6 parts and 8 is into 6 parts. So together, I would have x plus 8. And those are not like terms, so I have to keep them separate. So that's what my answer is going to look like, x plus 8 over 6. Okay, so now we're getting some pre-algebra stuff now. Let's take a look at this next one here. And again, if you know your multiplication facts well, then I recommend you just choose it, at least common multiple. But if you don't, 9, 18, 27, 36, and then 3 would be 3, 6, 9. Okay, I can stop there. I see a 9 will be their first multiple that they share in common. So for my fraction, I'm going to go ahead, I want them to be in the same number of divisions. So the first fraction I want into 9 divisions, and the second fraction I would like to have in 9 divisions, with the plus sign in the middle, which is important. And I'm multiplying 9 by 1 to get 9, so I also need to multiply the x by 1. I'm multiplying 3 by 3 to get 9, and so I need to also multiply the numerator, 5 by 3. From there, 1 times x, again, is just still x. We don't need to write the 1 in front of the x because we know it's there. The identity property multiplication says that I can multiply 1 by anything and it'll still be the same. And then on the second fraction, like I said, we've already done this part for both of them. Now we've done that part. And so now I need to just finish up with 5 times 3, which is 15. So when I add the fractions together, I have the same number of divisions, and I'm adding x plus 15, but those are not like terms, so I need to put them both up there separately. X plus 15 over 9. And again, another example. We got examples for days on this PowerPoint. So 7, 14, 21. I want to find the same number of divisions in both of them. So you can make a big long list, and I know I'm going to have to keep going for this one. So 56, 63, 70. I'm going to stop there. 10, 20, 30, 40, 50, 60, 70. Okay, so I see that 70 would be the first one that they share in common. Now that might be something that you can do mental math. You don't have to make a list, but I'm just trying to find the least common multiple here. And so in this case, I noticed that the multiples of 7 and 10, the smallest one that they share in common, would be 70. So let's go ahead and use 70 as our common divisor. And we have a plus sign in the middle, so I'm going to make sure I put that. That's important too. And to get to 70 from 7, I would multiply it by 10. And to get from 10 to 70, I would multiply it by 7. And so because I'm multiplying 10 times 7, I also need to multiply 10 times x. And because I'm multiplying 10 times 7, I need to multiply 3 times 7. All right. And so you can see that here, this fraction, 7 over 7, is the same as 1. This fraction here is 10 over 10, which is also 1. And so I'm just multiplying this fraction by 1. So it's not changing what it's worth, it's just going to change what it looks like. So I'm going to go ahead and do my 10 times x, which is 10x, and I'm going to go ahead and do my 3 times 7, which is 21. And again, I do not have any like terms on the top, but I'm going to keep the number of divisions the same. 10x for the first fraction and 21 for the second. Okay, because they're not like terms, I can't just squish them together. I can't make that into 31x. I can't squish it together anyway. Other than that, I just need to keep each term separate. Let's just look at a couple subtraction problems and then we'll call it a day. On the first subtraction problem, I see 5 and 6. Now, instead of writing a list out, I'm going to go ahead and cut right to the chase. So I think almost everybody had a good example of how to find the least common multiple. I'm choosing 30 because I know 5 and 6 both go into 30, and that's the smallest number that they both go into. This time I need to make sure to put a minus sign because it's a subtraction problem. 5 changing into a 30 would be multiplied by 6. So I need to make sure to multiply the numerator by 6. 6 multiplied by 5 would be 30, so I need to go ahead and make sure I multiply the numerator by 5. My 6 times 5 is where the 30 came from, so I need to multiply 6 times 4x, 24x. 6 times 5 is where that denominator came from, so I'm going to multiply 5 times 5, 25. Again, I have the same number of divisions now. I have a common denominator is 30, and 24x minus 25 is just 24x minus 25. They're not like terms. Now, if 25 had an x on it, they would be like terms, but x's and constants are not allowed to go together, so this is the best answer we can come up with. Right, and again, I'm going to go ahead and use mental math this time for my common denominator. If you need to make a list, please do. Between 11 and 7, I know that the least common denominator would be 77. It's the smallest number that both 11 and 7 go into. I make sure I wrote my minus sign so I don't forget which operation I'm using. And I know that changing 11 to a 77 would be multiplication by 7. So I need to go ahead and multiply the top by 7, 42x. And changing a 7 into a 77 would be multiplying it by 11. So I'm going to go ahead and multiply 4 by 11, 44. So now it's just a matter of combining the fractions together in a subtraction problem on the top. 42x minus 44 is 42x minus 44. If there were like terms, then we would have to put the like terms together, but in this case we have an x term and a constant term. So that's it for today, adding and subtracting fractions with variables.